Alright, let's continue this example of this cubic polynomial. Alright, we've seen that x plus 5 is not a factor, right? Did not have a remainder of 0, is not divisible. So let's see what happens with x plus 1. That was also a possibility they gave us as a factor. So we'll go ahead and set it up. Let's do long division. Let's see if x plus 1 will divide into this cubic polynomial without any remainder. Is it divisible by x plus 1? So again, long division, first term in divisor, first term in the dividend. Let's put in a different color. X divides in x cubed, exactly x squared times. As we multiply through our divisor, x squared times x is x cubed. X squared times 1 is x squared. And we subtract to see what's left over. Those cancel out. Negative x squared. Now remember, minus x squared makes a negative 2x squared. And we'll go ahead and bring down our next term in the dividend. And so now our dividend is a quadratic polynomial. Leading term, negative 2x squared. Well, x divides in negative 2x squared exactly negative 2x times. So again, we're forming our quotient up here. As we distribute that through, negative 2x times x, negative 2x squared. Negative 2x times 1, negative 2x. Subtract, see what's left over. Well, negative 17x minus negative 2x, that's plus 2x. So that makes a negative 15x. And we bring down the next term, which is the last term, the constant term. Well, x divides in negative 15x exactly negative 15 times. So we distribute that through. Get a negative 15x with negative 15 times x. Negative 15 times 1, negative 15. So we subtract. See what's left over. You notice everything cancels out. So this time, we have no remainder. The remainder equals 0. So that implies x plus 1 is a factor of this degree 3 cubic polynomial. It's one of the 3 linear factors. Alright, so with that said, let's go ahead and look at this problem as a division problem. Let's check our division. Alright, we're going to use division to finish out the factorization, these 3 linear factors. So remember, now we can always check division, right, by multiplying our quotient, right, times our divisor, plus any remainder, to see if it equals. So let's check it. So we know this cubic polynomial. Let's go back and put it in black. So x cubed minus x squared minus 17x minus 15. We know it equals, so based off properties division, right, divisor, x plus 1, times our quotient. Now here's our quotient up here, right, it's quadratic. X squared minus 2x minus 15. We know those together, multiply together, make this cubic, since there's no remainder, right, to tack on. So this gives us a factorization. So there's our divisor times our quotient, right? And you could check it, you could distribute, and you'll get x cubed minus x squared minus 17x minus 15 back. Well, while we're at it, we all know how to factor a quadratic trinomial. So let's go ahead and break it down to its 2 linear binomial factors. We need an x and an x up front for x squared. We know we look at that constant term, find a factor combination of 15, like 3 and 5, that work together again to make this middle term negative 2. Well, 3 minus 5 is negative 2, so we need a plus 3, and we need a minus 5, right? We're going to check it. So again, negative 5 times x, the outer product, negative 5x, the inside product's 3x. Yeah, they add up to negative 2x, 3x minus 5x. 3 times negative 5 is negative 15. So there's our linear factorization. So here are the 3 linear factors for this degree 3 cubic polynomial. So in the end, we know exactly what 3 factors are. So if you remember, we tested x plus 5 earlier. Well, it was x minus 5 was the factor. And they've asked us to do x plus 3, so we know it's one of the 3 linear factors, along with x plus 1. So again, you can see how we can use division to factor our higher degree polynomials. Okay, so I hope